Hi there. In this video, I will tell you how to use the 4-digit 7-segment display module, which is the TM1637 based display. This particular display module is quite easily available on various hobbyist electronic stores. So if you are buying it online, I think you'll easily find this one. There are four digits on this particular display. Primarily, you could use this for displaying a digital clock, or you could also use it for displaying temperature or humidity readings, assuming you have a temperature sensor or humidity sensor, a temperature humidity sensor connected on your microcontroller. So I will tell you how to connect this particular display on a Raspberry Pi Pico and try to use them through MicroPython, right? This particular display comes with 4 pins. Basically, this display is powered by 2 pins, which is the VCC and ground, and you can power it from 3.3 volt to 5 volt supply, shouldn't be a problem. And there are 2 pins to which you send serial data and clock. So if you look at the back side of the display, you will actually find the actual pin layout, which is listed in here. As you can see that you can see a clock. The first pin that you see here is called as clock pin, followed by DIO, which is where you send serial data. The numbers to be displayed sent as serial bits of zeros and ones, and that's how this microcontroller that's there in here on board will try to decipher that serial data and actually try to light up the LED segments, which you can see in the side, right? On the side. So you can send clock, DIO, and also you can connect this to the supply, that's VCC and ground. So in order to connect this, an easy way to do it is maybe using a small connector like this, right? You'll find this kind of jumper wires. It's also called as a Berg connector. There's one side is a female pin out, which you can see here, which you can connect to this particular pins. So I'm just going to do that right here. Let me just try to lay it out accordingly. I'd like to keep the pins which I select, the colors which I selected. I want to use some color coding. It's not the best, but I want to use the red for VCC and the brown for ground. And I'm going to use these 2 pins for the clock and DIO. So let me go ahead and wire it across. So connect the ground pin. Now I'm going to connect the VCC. And I'm going to use the DIO and clock. And I'll make a note of the colors which I've used. So here's it. So I just connected the pins in here. And the other ends are basically male connectors. As you can see, they're male connectors. And this you can connect it on the breadboard. If at all you have a female to female connector, you can directly connect it on a Raspberry Pi Pico H as is, right? If you have a Pico with headers, you can directly connect it across. But I'm going to use a breadboard for convenience because I might be connecting other devices also. So as I want to show a temperature sensor being connected to. So I'm going to use a breadboard. And the breadboard I'm using is a shorter one, which you can see right here. Let me just try to reduce the zoom a bit. Yeah. And as you can see that I'm using a Raspberry Pi Pico W. So there's a Wi-Fi chip on this board. Other than the fact that there is a Wi-Fi module on board, the pinouts are all the same, just like the Raspberry Pi Pico that you normally use. So if you can see, it almost looks identical in here. So one more thing to note is that the breadboard is a little shorter. You can see that is almost like half the size of the standard EMB102 breadboard. It's a 170 pin breadboard, so it's got half the size. But I think if you're not going to be connecting a lot of devices, you want to save up space, you can get this breadboard, or you can put it on the bigger breadboard also. So here I've connected, I've actually plugged in the Raspberry Pi Pico W on the breadboard, and as you can see, there are 2 wires connected in here. If you see from the pinout diagram, I think the pin number 40, that is the last pin that is there here, this represents the VCC, right? This will provide the supply that you get from the micro USB port when you connect it to your computer, right? So I'm going to be using that pin and connecting it on the positive rail of the breadboard. And the next pin is supposed to be VSys. I'm not using that. You can actually put this wire on VSys if you want to. It's perfectly fine. Rather, I'm using the next pin, which is the pin number 38, which is supposed to be the ground pin. So I will just show you the pin diagram in a while. Just a minute. Just one moment. Yeah, here it is. Yep. So we look at the pins which you can see here. I've just used the V bus pin connected on the positive, and the ground, which is pin 38, I've connected onto the negative rail of the breadboard. So I'm just doing this to make sure that it's easy for me to wire up other sensors. Okay, and I'm going to connect this particular display on this particular Raspberry Pi Pico. In order to do that, I'm going to select the positive, which is the red wire that's connected to the positive of this particular display module. I'm going to connect the positive onto the positive rail, and the ground, I've used the brown wire for ground, so I'm going to be using that end to ground in here. As you can see, let me zoom this up a little bit. Yes. And then what I'll do is there are two pins which are there here. One of them is the DIO pin, which is where you send data. And then there's another one, which is the clock pin, which is what I've connected with the yellow wire. The yellow wire goes to the clock and the orange goes to DIO. You can use any GP pins for this too, right? This particular display, which I have here, does not use any special protocol like I2C or SPI. It's got a special its own serial for connection. So you can actually use these two pins to be connected to any of the GP pins that you see here. So if you look at in the pin diagram, you could use any of the GP pins. You could use anything that's shown in green here, right? You can use GP28, GP27, GP26, or you can use 22. So all of these can be used on top side or on the bottom side. There are so many GP pins are there. You can choose any one of them as per your convenience. What I'm going to do here is I'm going to keep it more easier. So I'm going to use the last two pins of the Raspberry Pi Pico, which is GP16 and GP17. So I'm going to connect it there. So I'm going to connect the orange to GP16 and yellow to GP17. That's it. So the connection is done, as you can see right here, right? So GP16 and GP17 is where I've connected this particular display along with the supply as usual. Now, once the connection is being done, the next step is to program it, right? So in order to program this particular display, you will need to install the TM1637 LED driver. And it's available on the GitHub URL. I will just share the link to that in the description, but I'll also show you how it can be downloaded and added into your Raspberry Pi Pico, and then how do you use that library to program it. So first, let me connect the Pico onto the micro USB, which is connected to my computer. Right, this is done, and okay, this cable is a little fuzzy, so let me just put something on top. Yep, just a moment. All right, yeah, I think it's there. The cable is a little fuzzy. I need to actually hold it somewhere, but it's just okay. I'll let it be. So now what I'll do is I'll just switch the scene to show you the screen share for accessing via MicroPython. So, and downloading the TM1637 display. All right, so as you can see that in the shared screen, you can go to a website that is github.com/mcauser. That's, I hope I pronounced it correctly. It's Mike Causer. So his website, his GitHub URL, that is /micropython-tm1637. So once you head out to this website, which you can see here, you can see this represents the driver. There's a detailed documentation on how this can be connected. In fact, you can see a nice diagram showing with the Raspberry Pi Pico and also to install it and all that. I've tried using the MIP installer, but it sort of didn't work on my computer. I'm not sure why. I need to debug that. I need to find out. Maybe I may be using a different version of Thorny, perhaps. I'm not sure. So yeah, that could be a problem. But anyways, it's pretty straightforward. All you can do is either you can try installing using the process shown on the website here, or an easier way is when you look at the source code here, just click on this TM1637.py that you find here. The source code is anyway shown up. You can click on the download raw file button. Here you can click on download raw file button. So when you click on this, this will download the file right here, which you can now upload onto your Raspberry Pi Pico, right? But otherwise, if at all you want to just copy paste, you can select raw mode. Shows in raw mode. I'm going to just select it by clicking on the browser and type Control A, Control C, select all, copy. And then I can just fire up the Thorny IDE, which I will do right away. Thorny seems to have automatically detected the connection to my Raspberry Pi Pico because it's already connected on the micro USB, as you can see here. So what I can do now is you can also see an untitled shown up here. It's a new tab. You can, if you don't see this tab, you can click on new to open up a new tab and select in here and type Control V to paste it. And now what you can do is you can save this file in your Raspberry Pi Pico board. So to do that, I can just click on File, Save, or I can click on the Save button on the toolbar. So when you do that, select Raspberry Pi Pico, and for the file name, you can type TM1637. Yeah, the file extension is important. It should end with .py, and the file name, it's better you maintain the name as TM1637. Otherwise, you have to remember what is the name of the module, right? This file is being saved. Now let's go ahead and test it. In order to test this, you can just try at the MicroPython shell prompt. I just clear the screen by the shortcut is Control L to clear the screen, by the way. So once I clear the screen and you can see the shell prompt, you can try this. You can say from machine import pin. In order to configure the GPIO pins, you need to actually import the pin class from machine. And then this particular file that I've downloaded and stored in TM1637.py is now a module which I can load by using this technique. I can say from TM1637, there's a class inside it called TM1637. Yeah, note the cases. You can see the class names are all caps. Even when you use the pin, P is caps. Okay, so it is case sensitive. Python is case sensitive, right? So select this. It loaded, no problem. Now, in order to access this particular display, you could actually type, maybe you can type display is equal to TM1637 of. You need two parameters. This particular class takes up to 3 parameters. The third parameter is optional, which is the brightness. You can always set the brightness later. But you can say TM1637 off. You can say DIO is equal to. Basically, you need to know to which pin the DIO is connected. The DIO that is here, it's an orange wire that is connected to this particular pin on the Raspberry Pi Pico, which is apparently GP16. So I'm going to use DIO is equal to pin of 16, comma. The clock is a neighboring pin, which is where the yellow wire is connected, which is pin 17. So I'm going to type CLK is equal to pin of 17. If you want to set the brightness, you can also set the brightness by passing brightness is equal to. The values range from 0 to 7, but on all my displays, I've seen that there's been no difference in the brightness beyond the value of 3. You can check it out. So it might be the display that I bought. It only has about 3 or 4 levels of brightness. So some of them can come to up to 7 or 8 levels of brightness. So that could be the reason. So anyways, I'll just leave it as it is. And now when the display is instantiated, one thing to note is that in some displays, you might see certain random LEDs light up at the moment you say this. It's not a problem. It's just that it looks like the display is not properly initialized perhaps, but it's okay. If you see any one of the random segments being lit up, that's perfectly fine. You can always clear a display by using display.write. I'll talk about that. So now you can actually type display.show. It's a very convenient way to display a string. There are many methods available in the TM1637 library, but the easy methods for you to use If at all you want to display a string like data, you want to display a string of digits, then you can say show of, maybe and just type 1, 2, 3, 4 like this. As you can see, I'm not sure if you can see it on my screen. Sorry for this. Yeah. You can see it actually shows up 1, 2, 3, 4 here, right? Let me remove the lighting, move the lighting across so you can see it better. Yeah. You can try display.show of 0, 0, 0, 0, or display.show of, let's try, anything. We can also put some strings. Certain strings which represent alphabets will also be displayed, like A, B, C, D, E would work. Not all alphabets will work. If you try some complex alphabets like K or X, they all show up identically. So if we try to say display dot show of K, X, and maybe H, and what else? Maybe I'll say R. Well, they don't show up any different, right? So that's the limitation with the 7-segment display. It's primarily meant for displaying digits, but a few alphabetical characters can be displayed, but some of them have ambiguities, right? So if you want to display more exotic fonts and ambiguity, a lot of fonts and so on without any problems, then I think it's better to go for an OLED display or a proper 16:2 or 20:4 LCD display, which I will cover in the next couple of videos, right? For now, this is what you should know. R does come up. R is shown as a small r like this, but you can see that H, X, and K, fortunately, this is how it will be shown up. They're all shown like H, right, on the display. But of course, you can use it for displaying strings. Not just that, you can also display numbers in another way. You can type display dot numbers of. This is useful for displaying clock. So if you want to display something like a digital clock, you could try display numbers of, you can type 1, 2, comma 3. There are two numbers, and these numbers I would recommend to be 2-digit numbers. If you try 3 digits, it may not work. So when you try this out, by default it also prints a colon. You can also see a colon being printed in the colon being displayed, right? Useful for displaying numerical information. Maybe I can just zoom this up a bit to show you, to give you a better view. You can see the colon also being displayed in here, right? But of course, if you don't want the colon to be displayed, you can always put comma colon is equal to false. So if you want to represent clock, I think using display numbers will be convenient. I will show you why. But sometimes you want to display something like temperature, right? There's a high-level method that actually provides a simpler way to display temperature. So if you want to display temperature, you can type display dot temperature of, I'm just going to put a number like say 24, hot coded, right? And you can see that it shows as 24 degree centigrade. It shows in Celsius. Yeah, I think the author lives in a zone where they measure temperature in Celsius, like me. Even in India, we use Celsius. But if you happen to use Fahrenheit, so I think you can just customize your code accordingly. But I think by default displays in Celsius or centigrade, right? This code is open source, so you can always, if you look at the source code, you can see there are a lot of methods available. In fact, this is a TM1637 class that I was showing you. And the init method does take CLK, DIO, and the brightness as a default argument. So even if you don't pass it, the brightness set to the maximum level. If you want to change the brightness to lesser value, if you don't want it to be too bright, if you want to dull down the display a bit, you can always say display dot brightness of, you can try numbers like 2. You can see that it's a bit dull down. You can try even values like 1, which makes it even more dull, right? So you can see that it's quite easy for us to interface this display onto Raspberry Pi Pico. Just use this driver and make things work. You can look up this class and you can see there are a lot of methods available. A couple of them are low-level methods like the write method, and you have methods like this write method is a low-level method where you can light up individual segments if you know the bit mapping accordingly. And you have encode digit, encode string, which takes care of converting a digit to the appropriate segment format, segment byte format. So you have all of these methods for you to look up. for you to explore. So the high level methods, if you want to use, you can use display.numbers or display.show for representing strings, right? So that's about it. The next video, I will tell you how to create a temperature sensor using the Raspberry Pi Pico, using this particular display module. And I'll also tell you how to create a small digital clock also, right? Thank you very much. Hopefully you found this video useful. If you do find it useful, yeah, do subscribe to me. So I'll be making more videos on the same line. Thank you very much. Hope to meet you in the next one.